Okay, so for the next questions, my colleague Lucky will talk with them. So, guys, feel free to ask him questions too. I'm sure you'll do a good job.
As already mentioned, it's Laxin Dube. Also, I'm going to take you for the next two questions, question number 4 and question number 5. Well, let me just clear up the board. Well, as already been mentioned, listen and learn and follow along as we are going to present it on the board. Is it so? Alright, let's do question number 4. Well, question number 4, it says that a quadratic pattern has a second term equal to 1 and a third term equal to -6 and the fifth term equal to -14. Now the question is saying, calculate the second difference of this quadratic pattern. Well, when you see a question like this, keep in mind the key terms there. It says a quadratic pattern. So now we need to know the principle of a quadratic pattern. Well, but we're told that the second term, which is T2, second term, is called 1. And then T3, third term, is called -6. T4 is not given. Okay, T4 is called T4. And then T5 is called to -14. Alright. Well, when you are told that it's a quadratic pattern, please present your work in a way that will help you to find the first difference and then the second difference. Alright. So now what we are going to do, the second term is 1. Okay? And then the third term, -6. Fourth term, T4. And then the fifth term, -40. When you are given a quadratic pattern, I will repeat again. Present like this. And then now let's find the first difference. Alright? Now, by the first, let's just do like this. So that you can be able to follow along. Alright, by the first difference we will say this third term minus first term. Right? So we're going to say -6 minus 1. Right? Because that's the first difference. Let me go to here. First difference. Alright? So now we say -6 minus 1. What is the answer? -7. And then T4 minus -6. T4 plus 6. And then -14 minus T4. What is the answer? -14 minus T4. Alright. Is it big enough? Okay. Now this is the first difference. But what are we required to do? The second difference. Now we continue again. Now we do the same again. This is second difference. Now we say this whole term minus this. Alright? So let me do this here so that we can be able to follow. Let's say we do T4 plus 6 minus -7. Always keep in mind to not to make a mistake in terms of deductions when you are given the negative signs like this. Right? You can do this. That's fine. It's proper. And then also here we say -14 minus T4 minus, and then we can say T4 plus 6. Right? Are you following? Okay. Now, this one, let's take it from there and then we write on the other side. Is it fine? So, T4 plus 6 plus 7. What is the answer? It's T4 plus 13. Alright. And then this one, minus 14. Okay, let's just deal first of all with numbers. Minus 14 minus 6. What is the answer?
Minus 20.
It's minus
20.
20. And then minus T4. Minus T4. What is the answer?
Minus 20.
Minus 24. Alright. We are on the second difference. But what do you understand by the second difference? Second difference, we have a common D, which means these two terms should be equal. Alright? These two terms should be equal. Meaning to say, we are going to say T4 plus 80 is equal to minus 20 minus 2 T4. Alright? And then let's group like terms together on one side. So we're going to take this T4, we put it this side. And then 18, we take it this side. This side. Alright. So we're going to say T4 plus 2. T4, what is the answer? 24. And then is equal to now 23. So minus 20 minus 18 minus 33. This is simple. So what is our T4? Negative 11. Alright. Now we got our T4. But what are we required to do? It says calculate the second difference. The D that we've been talking about, right? So like this one, the whole of it here is D. And also this is D. Remember on the quadratic, they should equal on the second difference. Alright. So we're going to put, either way, when you put here or there, we should get the same answer. Now our D is equal to T4 plus 80. Alright? Which is equal to, what is T4? Minus 11 plus 80. Which is equal to 2. Alright. So our D is 2. Even if you put it here, you still get the same answer. 2. Any question on this? So that's the first part, 4.1. Calculate the second difference of this quadratic better. 5 marks. Just keep in mind those necessary steps so that you get all the 4 marks. Alright. So let's move on to 4.2. 4.2 says hence or otherwise. Hence or otherwise, calculate the first term of the separator. Now we now want the first term. But if you are told like what my brother told you, hence or otherwise, which means you are going to use the previous information. Alright, so let's keep in mind T4, right? Okay. Now let's turn. Let's give me some time to erase this. Okay. Now we want to calculate the first term. Remember that it starts on the second term, right? So let's just say T1, first term. And then the second term, what is the answer?
Right, Beggar, please, and please start it again.
Okay. T1, and then the second term is 1. Third term, minus 6. Fourth term, T4. And then the fifth, we're given minus 40. Okay, but we have been working with all these before, like from here. So now let's do this. First difference. Alright. Now let's just repeat the same scenario. Like first difference, what you get here? 1 minus t1, right? 1 minus t1. Second difference?
Minus 7.
Not second difference, but it's the first. So I put minus 7, and then the t4 plus 6, right? And then minus 40 minus t4.
I have a question. Since, okay, when we were calculating at first, we got the difference of the T4 and so can't be substituted here.
Yes.
So instead of T4, can't you write the negative later?
Yes.
Instead of writing T4 here.
No, that's fine, thanks. But I don't know if I will introduce it a bit when we are not following. But it's fine, we can, that's why I said hence or otherwise. So which means we are going to use that T4 that we get from the previous way. Alright? Okay, so now here now, let's do the second difference. Okay, so it's minus 7 minus this, what are we going to get? Minus 8 plus T1. Alright? And then here we are going to get T4. Remember, we can put what we got, minus 11, isn't it? Alright, let me erase it and then put minus 11 there. So minus 11 plus 6. So minus 11 plus 6, which gives you?
Minus 5.
Minus 5. Minus 5 minus 7. 2. It gives us 2. Alright. Again, this should be equal. Alright. According to the quadratic pattern. So we are going to get minus 8 plus T1 is called 2. Then T1 is called 10. That's the first term of the pattern. You can ask a question.
I wanted to ask the difference between negative 7 and 1 minus T1 is negative 8 plus T1, right?
Yes.
And then the next one is 2. Why are we like looking for the difference on the third part?
On the
third part.
on this one again.
Yes.
Okay. This one will be what now? Plus 11, right? So what are we going to get?
2.
Okay, let me put plus 11 here. So that will be 4. And then this one will be minus 3.
Yeah.
Minus 3 plus 11
Minus 14.
minus 40 plus. Is it fine? No, this is minus 3, right?
Yeah.
Yes.
Minus 3. And this is what?
Six plus
Minus 5.
negative 5.
So minus 3 minus 5. What is 2? 2. I just use this because even if you take it from there, you get the same answer. Remember, our concentration area was to get T1. Alright. Is it clear? Well, there are many methods of working out this. You can use the other ones, which are but this one is more simpler and is even straight from your book. You can just remember it and then you apply it. Right. Now we come to the interesting question 5. To the interesting part of mathematics. Now let's look at 5.11. Now it says that consider the function f of x is called minus 6 over x minus 3 minus 1. Alright. Now it says 5.11. Calculate the coordinates of the y-intercept of f. Whenever you're told y-intercept, what should be the value of x?
0.
0. That principle holds everywhere. Alright. So coordinates of y-intercept, which means we are putting x is equal to 0. So we say, remember how it's f of x is equal to minus 6 over x minus 3 minus 1. So wherever there is x, we are putting 0. So now f of 0 is equal to minus 6 over 0 minus 3 minus 1. Punch in your calculator, what you get?
1.
You're going to get 1, alright? So that's your y. Okay, but what was your x? 0. So when x is 0, y is called 1. We done. You can even write like this: 0, 1. It's 2. Alright. So we are done. Calculate the coordinates of y-intercept. Those are the coordinates: 0 for x and 1 for y. Alright. This is simple and pretty straightforward. Now let's do 5.12. Now it says there, calculate the coordinates of x-intercepts of y. X-intercept meaning that, what is the value of y? 0. Straightforward. Now we go, remember f of x also means 1. That's it. So we can just take it from there and then we say 0 is equal to minus 6 over x minus 3 minus 1. Now, you take 1 to the right, right? And then it becomes positive because it's negative on the right hand side. So when it goes to the left hand side, it becomes positive. So 1 is equal to minus 6 over x minus 3. 1 is like 1 over 1, isn't it? Cross multiply. Not cross multiply, right? Okay, let's do it on the next. So which means this one is going to multiply by here, and this one is going to multiply by that. Alright. So remember, it's like 1 over 1 is called minus 6 over x minus 3. So meaning that we're going to get x minus 3 is called minus 6, right? X group like terms, you can always keep that in mind. 3 goes that other side, alright? So x is called minus 6 plus x is called right. And then what is y? So these are the coordinates. Minus 3 and done. Pretty easy. Okay. 5.13. It now says sketch the graph of f in your answer book. Alright? Showing clearly the asymptotes and the intercepts with the x's. Now what you need to keep in mind when you are told to sketch the graph. Now keep in mind y-intercept, x-intercept, and the asymptotes. Always keep in mind those things. Y-intercept, x-intercept, and the asymptotes. Now, we are given that graph, but let's keep this our points in mind. These coordinates or the y-intercept, because we already calculated them. Okay, I'm going to erase this pattern so that we can be able to draw it nicely. Okay, 5.13. Okay, so now when we are drawing, let's draw our this is y, this is x, right? Now, first of all, let's do the asymptotes. Right? For the asymptotes there, f of x is called minus 6 over x minus 3 minus 1. For the asymptotes, first of all, we are going to look for the x's asymptote. Alright. What is it? Simply what I said. Alright. Now for the x asymptotes, asymptotes is very simple. By asymptote, we are saying the line is not going to, or the graph that we are going to draw is not going to reach that line. Alright. So if you look carefully on that question, just imagine, put 3 there on x. 3 minus 3. What is going to be 0? Minus 6 over 0. Undefined. So which means it's not going to touch minus 3 on the x axis. Alright. It's not going to touch 3. Sorry, not minus 3, but 3. Okay, so we are going to put on the axis our 3 there. This is the point that you only need to mark. Don't worry about the other points because you are sketching, right? So we put as in asymptote. Alright. Now look at the y. The asymptote there is going to be what? 1. It's going to be minus 1. Now if you were to do the transformation, if I can take you back to the transformation of graphs, you see that that graph has been dropped 1 downwards, alright? So we are going to put minus 1 on the y axis, alright? So this is going to be minus 1. And then we're also going to put our asymptote there. So now we are done with this point. The other point that we need to keep in mind, the y-intercept, where the graph is going to cut the y-axis. Where is it? We've done it. Right. We got 0 and 1. Alright. So we're going to have, this is 0, the origin, right? And then our 1, let's put it somewhere here. So this is 0, 1. So which means our graph is going to cut at that point. And the other point, the x-intercept. -3, 0. Now we'll keep that point in mind also. Now what is left? That's it. Now, if you look, from what you know from the exponential or that graph, type of a graph, right? What kind of a graph is that? Hyperbola, right? It's normally drawn like this. Alright? But because of negative on the 6, that's why your graph is going to come out like, remember when it's negative, it's a reflection on the y-axis. Right? Mathematically to come out nice even when you want to check whether you've done it correctly or not. Okay, so now we are going to have our graph going there, passing through that point. Also passing through that point. Oh, my drawing there is poor. Okay, but that's how it is going to be done. And then also you come here, you do the same. This is so the major point that you need to know, this point, the asymptote, done. And then you get your 4 marks on that. Alright? It's 4 marks. But you need to draw all these 2 lines because it's a hyperbola. Okay? Any question on this? Clear? Alright. So now the next question, 5.14, says, for which value of x is f of x greater than 0? Remember, f of x is what? Is your y. So we just check here. Where on this graph are we going to have on the positive? Remember, when it's greater than 0, which means your y is what? Positive. Alright. 5.14. So f of x greater than 0, which means you are looking on this positive side of the graph, not on the negative, alright? Because it's greater than 0. So we are going to look, you start from this point up to this point. You see, that's why the graph is going to a positive, or is greater than 0. F of x greater than 0. Are you following? So meaning to say that we are going to have from -3 to where? To 3. Alright? That's where we're going to have our graph on the positive side. Done. Or you can say -3 is less than x is less than 3. Is one thing. Yes?
There's something I don't get. You said for which values is yeah, there's y greater than 0, right?
Yes, for which values of x?
Yeah.
Yes. F of x greater than 0. Yes.
Oh, which values of x? What I wasn't understanding was I thought because of that f of x same as y, we were gonna say the 0 and the 1, but then, yeah, same as the second as of x. I thought we were discussing it.
That's it. So whenever you're looking at a question, make sure you understand it before you attempt it. Okay, let me repeat it what it wanted you to do there. It says, for which values of x is f of x greater than 0? Or you can just put it simply to say, where is our graph going to be on the positive side, so to speak? Remember, our graph is all this. So where is it going to be on the positive side? Remember, y is positive here and negative there. So on the x's value, we're saying our y is positive, this portion only. So on the x, we're starting from -3 to 3. Remember, it's not going to have anything there. When it comes here, just after this point, it's now on the negative. So we need to really answer the question what it says, right?
So if I should put the question in my own words, it says that where are the values of y on x greater than 0?
For which values of x is this graph, or y greater than 0 or positive? I don't know if it's clear. It's clear. Alright, so that one is done. Now it says 5.15. Calculate the average gradient of f between x is equal to -2 and x is equal to 0. Alright, now we are looking at the average gradient of that function that we have here. But on which points? On x is -2 somewhere here, and then x is equal to 0. So we're just going to look at this portion. But now, to get gradient is very simple. We cannot even not use this graph. Alright, then now let's use the formula to get the gradient, right? So now, gradient, we are doing 5.15. Alright. To get the gradient, remember, let me just remind you on the formula. We say y2 minus y1, no? Over x2 minus x1. Alright. Now, here we are given two values of x, -2 and 0. So we also need to find the y values or the f of x values on that range on that domain of -2 and 0. Alright. So we're going to say gradient. Now we can just say f of -2 minus f of 0, right? All over, what is the x value? -2 minus 0. Okay, you follow? So now, what is f -2? We put in that our function, right? Okay, let me work it somewhere here. F -2. Whenever there is x, what are we going to put? -2. So we're going to have -6 over -2 -3 -1, which is going to give us -6 over -5 -1. Okay, what are we going to get there? If you plan to calculate it? 1 over 5. 1 over 5. Now, how about f0? We got it to remember. What are we going to get? This one will become 2, right? -1, which is 1. Be very careful on this. But the signs sometimes many so they confuse on the signs, but then they get it wrong. Okay, so now we are going to get what? That one is correct, eh? Okay, then we're going to get 1 over 5 minus 1 all over minus 2. If you can't, you can do what I mean. Yes. You won't get minus 2 over 5, right? 2 over 5. Done. Be careful. I will repeat. Be careful on how you use your calculator. Because 1 over 5 minus, you're going to get minus 4 over 5. Minus divided by minus will always give you positive. That's why we shouldn't get a negative. Right? And even if you were to come here, you're looking at the gradient of this, right? It can't be negative. Right? You see, because the line is. Okay. So now we are done with the average gradient of f between minus 2 and 0. Just memorize. Don't forget the formula. And the input, then you get the answer. Okay. Now the last one, on question number 5, it says, draw a sketch graph of y is equal to a x squared plus bx plus c. Right. Give me a moment to do this. What it says here, please take note of those conditions that are given there. Where a is less than 0, b less than 0, and also c. And that condition that ax squared plus bx plus c is equal to 0 is only one solution. Alright? So now let's draw our Cartesian plane. This is y, this is x. Now I'll say draw a sketch of a graph. When you're about to draw a sketch, don't worry about doing it properly or just draw a sketch with key points. Now that graph is a quadratic graph. So when you use a quadratic graph or quadratic function, you need to know that it has got what? Turning point. One turning point. Alright. But now, from what you have learned about the quadratic, when a is less than 0, what is it going to be? Okay, let me just take you. When a is greater than 0, it's going to be like this, alright? When a is greater than 0. When a is less than 0, it's going to be like this. Alright, keep that in mind. Always remember that. So now we are told that the a is less than 0. So our graph is going to be like this. Just second. Alright. So now we are also told that b is less than 0 and c is less than 0. What is c on a quadratic graph? Now, c is always y-intercept. C is y-intercept, which means where the graph casts the y-axis. Now, it's going to be less than 0, which means it's going to be down somewhere here. Alright? So now, we have two conditions now. Our graph should be like this, and it should catch on the bottom here. But now, how about the turning point? Which side is it going to be? Okay. To get the turning point, we get it by saying x is equal to minus b over 2a, isn't it? That's how you get the turning point, the x value of the turning point. So now, remember now, our b is negative, is less than 0, isn't it? And also a is negative, is less than 0. So meaning to say, our x value would be on this side, on the negative side, isn't it? Let me even try to prove it minus, and then if b is, since it's less than 0, it's minus, right? Over 2 minus again. So meaning to say this will be positive and negative. So by the end of the day, it's minus b over 2a. So meaning to say our x value will be on this negative side, that's the turning point. The reason that they gave us that it has got only one solution, it means that it's going to turn on the axis line, on the x-axis line, alright? If it has 2 points, it's going to turn like this, alright? But if it has got 1 point, it's going to be just there, like this, alright? That's why they gave us that condition. So now let's answer the question. It says there, where a is less than 0, b less than 0, a, and also there's one solution. So we are going to have a turning point here, and it's going to cut. We've established that it's on this negative side because of this condition. It's going to turn like this because of that condition. It's less than 0. It's going to cut down here because of this is less than 0. We are using all those conditions. Keep them in mind, alright? So this one, we have the our C, and this is turning point. That's the graph. And then you just label it. Y is equal to a x squared plus bx plus. Yeah, that's a sketch of our graph. Is it clear? I've tried to input a lot of things. Let's hope you've been following. So follow these conditions that you are given. One solution, it should always be there. Negative is gonna have a maximum point like this, alright? Any question on this? So the one of question 5 is done.
Okay, moving on to the paper, we're on question 6 now. It reads, the graphs of f of x is equal to 2 to the x minus 8 and g of x is equal to ax squared plus bx plus c. They're sketched below. So the graphs of those two are sketched below, and b and c are the y-intercepts of the graphs of f and g respectively, and the two graphs intersect at A, which is the turning point of the graph of G, and the x-intercept of the graphs of f and g. Okay, then the questions read, determine the coordinates of A and B. Okay, to make this easier for us, I will draw the diagram so that we can relate to it as we go along the question. Okay. Okay, so we've got our two equations. We've got f and we've got g. That's your x-intercept. That's your y-intercept. Okay, and the first question is based on those two, the y and x intercept. So they say determine the coordinates of A and B. Okay, so what you should ask yourself here is, what are you given? You're given an equation for f of x. It's 2 to the x minus 8. Then you're also given an equation for g of x. That is ax squared plus bx plus c. Okay, if you think about it, you can only really use f of x for now. Because the other, you don't know the variables for a, b, and c. You don't know what those stand for. So let us work with f. Since f actually passes through both points, that point and that point, what do we know about intercepts? Along the x-axis, y is 0 at that point. And along the y-axis, x is 0. So we'll use that knowledge to solve for a and b. Okay, so let's start off with a. And we're working with f of x is equal to 2 to the x minus 8. Okay, at this point we know that y is 0. So in other words, 0 will equal to 2 to the x minus 8. Then we're trying to solve for x. We'll have to use our knowledge of exponents in this instance. Okay, so let's take over the 8 to the other side. Eventually we'll have 2 to the x is equal to 8. Okay, this is a base of 2. let's also put this to the same base. So 8 in terms of 2's is 2 cubed. And once these are the same, the bases, that means the top, you can equate the top part. So in other words, x will equal 3. Okay, so all in all, A will be a point 3, and we already know what y is. It's 0. Okay, everyone follows. That should be simple enough. Cool. So we know what A is. Now let's try get what B is. So B, what's happening there? Once again, we're dealing with f of x is equal to 2 to the x minus 8. At this point, we know that y is, well, not y, I mean x is 0, right? So we're going to say y will equal 2 to the 0 minus 8. What's 2 to the 0? 1. 1 minus 8 will equal minus 7. So therefore that means B will be the point. X is 0, but y is negative 7. Okay, that's an easy format. Okay, so with that mentioned, that will be question 6.1. I don't know if there are any questions. It's fine, eh? Okay, let's move on to question 6.2. Okay, so question 6.2, let me just write these points here. So that's 3, 0, and this is 0, minus 7. Question 6.2 says, write down an equation of the asymptote of the graph of f. Okay, what's an asymptote? We did that previously. That would be the line where this doesn't touch, yeah? Okay, and normally, if this point, we say that point is negative 7. Normally it's a space of 1. When we're dealing with exponential curves, okay, it's only a space of 1. Like, your standard exponential curve looks like that. And this point is 1. And the space between 1 and the x-axis is just 1. So, if that's minus 7, this should be negative 8. So, the answer there is simply y is equal to negative 8. Okay, and if you're in doubt, you can always take the equation that you're given. They gave it to us as f of x is equal to 2 to the power x minus 8. This part over there, that's your asymptote. So y is equal to negative 8. Okay, any questions with that? Okay, cool. Let's move on to the next question. Question 6.3. It says, determine an equation of h if h of x is equal to f of 2x plus 8. Okay. So, let's say determine h of x if h of x is equal to f of 2x plus 8. What would be f of 2x? If you think about it, if they asked you what's f of 1, what did you go do? You go substitute 1 where x is. So now they're saying what's f of 2x? You just simply go substitute 2x where x is. So f of x was 2 to the x minus 8. So we'll come substitute 2x where the x should be. And then it's minus 8. So that's the substitution for f of 2x. And the last part is the plus 8. Does everyone follow this step? Okay, so if it was just a normal constant, we would just substitute for a constant, a number. But now we substitute for an actual function, 2x. So we go substitute 2x instead. Okay, then this we can simplify further. If you remember the laws of indices, x to the a and you've got a b outside, that's the same as x to the a times b. So this you can simplify further by saying 2 to the 2 x. We're separating them because we know what 2 squared is. Minus 8 plus 8. Can you see? These will cancel. Then you're left with 4 to the x. So your final answer should be 4 to the x. And that should be your equation h of x. Okay. So that's question 6.3. I don't know if anyone has questions in terms of the method we used. It's fine. Okay. So finally, all in all, we'll have h of x is equal to 4 to the x. Okay. Let's look at question 6.4 now. They say determine an equation of h to the negative 1 in the form y is equal to something. Okay, h to the negative 1 means
The inverse.
inverse. Okay, so we're trying to find the inverse. So 6.4, trying to find the inverse. H of x we found to be 4 to the x. So in other words, you can write it as y is equal to 4 to the x. Okay. If you also remember, there's a law which says if you've got x is equal to a to the y, right? You can rewrite this as y is equal to log base of that x. Okay, that in a way is your inverse. Okay, we'll do it with logarithms. So that's one way of doing it. So in other words, straight from there, you can then say y is equal to log a is 4x. That's one quick way of doing it. Okay. So that's one method you could use, or you could say you're trying to, like, remember the rule, like one of the methods we've used to get an inverse. You make x a little formula, then you change the x's to y's, then that will be an equation. Okay, so just like you got y is equal to 4 to the x, try solve for x. In other words, make x subject to formula. In order to do that, we introduce logarithms. In other words, log both sides. What I mean by that, you say log y should equal to the log of 4 to the x. This x can come down based on one of the rules of logarithm. So this will become log y is equal to x log 4. Okay. Then eventually, we're trying to isolate the x. So the log 4 will go down. Okay. So we've got log y is equal to x log 4. Therefore, x will equal log y over log 4. Then last step is to change your x's to y's, y's to x's. So that becomes y is equal to log x over log 4. And this would be your h inverse. This is exactly the same as log 4x. It's the same thing. Okay. So that would be a question 6.4. I don't know if anyone has any questions based on the two methods used. Fine, yeah, ask.
My question is, how do you get log x over log 4 to be log 4x?
But this,
Yeah, how do you get it to be the answer?
like the one method, like it's kind of like a renaming. It's the exact same thing, only that the one method gives out a formula of using the laws of logarithms. We got log 4x. Then here we use the inverse method. Okay, but these are exactly the same thing. If you plug in, what's it called? If you plug in, let's say x of 2 there, and say log 2 over log 4, you get the exact same answer. We say log 4 2. Okay, it's just another way of writing that. Okay, that's fine, yeah. Okay, let's move on to the next question. So now we are on 6.5. So 6.5 says, write down an equation of P if P is the reflection of H inverse. Okay, this is just for 1 mark. For this, it's also one of those things where if you know your logarithms or you know what a reflection means about the x-axis, it pretty much is just a change of sign. So it should be a negative. So from the previous question, what we had y, that's for 6.5, where y is equal to log 4x. So simply px, which is the reflection of what we got in the previous question about the x-axis. About the x-axis, on top y is positive, at the bottom is negative. So it's just simply negative log 4x. Okay. In other words, now you won't work on the negative part, you work with the negative y now, because it's a reflection about the x-axis. So the y's become negative underneath the x-axis. So that negative transfers to the other side, and just simply log 4x. Negative log 4x. Okay, that should be easy to remember. Okay, so that's question 6.5. Now let's take a look at the last question. It says calculate the summation of k is equal to 0 up to 3 for g of k minus the summation of k is equal to 4 up to 5 for g of k. So now as you can see, we're no longer working with f. We're now working with g. Okay, and they want us to calculate the sum from 0 up to 3. 3 is over here. Okay, from 0 up to 3 minus 4 and 5. Okay, so the diagram is okay. It's not really skewed, but based on how they've drawn it, the quadratic is normally it's symmetric about the axis of symmetry, right? That point, that axis of symmetry is at 3. So in other words, it dissects the curve like that. Okay, what I mean by that is, if this is 2 per se, and let's say this point here is 4, these both give the same value over there. They're the exact same thing. Okay, even if this is 1, we take another step this side, maybe roughly there. These two are exactly the same at that point because of the axis of symmetry. Okay, we're going to use that knowledge to try to solve this. Okay, so we're working with the summation from k is equal to 0 up to 3 for g of k minus the summation for k is equal to 4 up to 5 for g of k. What does this mean? This means you're summing g of 0 plus g of 1 plus g of 2 plus g of 3. Then you're subtracting g of 4 and g of 5. Okay, so what I mean by that is this would be g of 0 plus g of 1 plus g of 2 plus g of 3. I'll put that in brackets to show that it's for that. Then we're subtracting I also put it in brackets, g of 4 plus g of 5. Okay, so we're subtracting the summation of g of 4 and g of 5. So all in all, we have g of 0 plus g of 1 plus g of 2 plus g of 3 minus g of 4 and minus g of 5. Okay, so in general, now we've opened up our brackets. So it's g of 0 plus g of 1 plus g of 2 plus g of 3 minus g of 4 minus g of 5. Okay, and all in all, we're just summing up what we're just putting this in terms of what they've asked us. In the end, we're going to point back to what I mentioned about what's going on because of that axis of symmetry, the values which each point gives. Okay, but before we move on, does everyone understand where we get these values from? Question, okay.
So isn't it the first summation we given that there are 3 terms?
Not necessarily 3 terms. Because there's a 3 there, doesn't mean that it's 3 terms. You start counting from 0, not from 1. If it was 1, then you'd say G1 plus G2 plus G3. But they specifically say start from k is equal to 0. So it comes G0, as in substituting for k into that G, right? So you substitute for 0, for 1, for 2, and for 3, and you add them up. Okay, so don't get confused by that 3.
But if you add those g's, they're gonna be 4.
Yes, there's 4 terms now. So in other words, maybe what's confusing you here is the 3. That 3 doesn't stand for term. They're just saying the value for k, not the actual terms. There are 4 terms. This means summation of g of k, where k is equal to 0, all the way up to 3. So you start from 0, 1, 2, and 3. It comes out as 4 terms. This doesn't indicate whatsoever that you should be getting 3 terms. Make sense? Okay. So even here, you count from k is equal to 4, then you count k is equal to 5. So that's why we've just got 2 terms there. Okay. So don't get confused. I know students might get confused by the notation, but all this is saying is the summation of this function where k takes on values of 0, 1, 2, and 3. Then the summation of g of k where k is equal to 4 and k is equal to 5. Okay. So with that mentioned, let's go back to what I was mentioning. Because of symmetry, this point 2 is one step from 3, right? This point 2 will be the exact same, will have the exact same value when x is 4. The point 1 left, because that's 2 steps back, will have the exact same value when you take 2 steps forward because of symmetry. So, in other words, we're dealing with g here. In other words, g of 2 should equal g of 4. G of 1 should equal g of 5. Okay. So what I mean by that, saying, just go back to the question. We're saying g of 2 should equal g of 4 and g of 1 should equal g of 5. Our equation, if I just rewrite it, was summation of g of k is equal to 0, 3, minus summation of g of k is equal to 4, up to 5. This was g0 plus g1 plus g2 plus g3 minus g of 4 minus g of 5. But then we're saying g of 2 is equal to g of 4. So g of 2 minus g of 4 should cancel out, because they are the same point. Okay, and g of 1 should cancel with g of 5 because they are the same. So all in all, we'll be left with g of 0 plus the g of 1 disappears, the g of 2 disappears, the g of 4 disappears, the g of 5 disappears. Question here?
And you said g of 2 and g of 4 can cancel out, right, because they're the same.
Yeah.
But then, what about the signs? We don't look at the signs. So
No, that's exactly why they cancel, because we're saying, it's like, by them being the same, let's say if this was a value, let's say if it was 2, let's say the whole value for g of 2 was 2, and we're saying g of 4 is also 2. Do you see you'd have 2 minus 2? That's why they cancel, because they're the same. Okay? So all in all, what I'm saying is this. If we come here, we're saying g of 1, then minus g of 5, plus g of 2 minus g of 4, plus g of 3. This g of 1 and g of 5, we say they're the same, so they become 0. So all in all, we have g of 0, this disappears, that disappears, plus g of 3. Okay, so now at this point, we've managed to cancel what we don't need. But we're still stuck at this point. G of 0 means, like, what's the value for y when x is 0? Let's go back to our equation, or rather to our graph. When x is 0, in other words, g of 0, do you see what the value of y is? They give it to us in the diagram. It's 4.5. So in other words, g of 0 is 4.5. And then we say there should be a plus g of 3. G of 3 is 0. You see that? So all in all, it becomes 4.5 plus 0. So the value for g when x is 0 is 4.5. The value for g when x is 3 is 0. So now we boil down to that conclusion. G of 0 is 4.5. G of 3 is 0. Your final answer should be 4.5. It makes sense? Okay. So I know it's a bit, because you're not working with figures per se, but then you can definitely make logical sense of it if you follow the rules. Everything I've mentioned is stuff that you know, you can relate. It's just taking it a step at a time, doing the most logical thing a step at a time until you get to the answer. Okay, but I know as well, me being a student, you'd see all those figures. You're not dealing with numbers, you're dealing with an ax squared plus bx plus c. You think, okay, where should I even start? But as you can see where we started from, we started off from the definition of this. They're summing the terms. That's where we started. And we subtracted that. Already you writing that step is good enough for you to proceed. Okay, then from there, the next logical thing, we opened up brackets. That becomes negative, negative. Then the only tough thing would have been to try and make logical sense of what's happening there. But already you've done excess of symmetry. The theory behind that is that everything here is symmetrical. If you take a unit back, 1 unit back, and 1 unit forward, those two should be the same. Take 2 units back, 2 units forward. Because it's symmetrical, those values should be the same. Take 3 units back, and so forth. Okay, that's the only part where maybe you need to think. Then once you understand that, then you see that some of these will cancel out. G of 2 and G of 4, because they're the same, they cancel out. G of 1 and G of 5, they're the same, they cancel out. Then they give you these values for a reason. That's where you use your knowledge to find what G of 0 is and what G of 3 is. Then that's where your answer comes from.